All right, so it is chapter 15. Okay, so first, the definition of a set. A set is a collection of objects called elements. Okay, let's start with the universal set is the set of all elements under consideration. We're going to call it U. Okay, also we're going to define the empty set. So it's empty, has no elements, contains no elements. Okay, this is the symbol for the empty set. I'm just going to put empty brackets, brackets with nothing inside. Let's draw a picture. So let's draw a universe. It's going to be a Venn diagram. And we like to make the universe a square. We'll put a set A. And inside this set, we're going to put the element X. And over here, let's put Y. Okay, so right now, our universe has two elements. U is the set that contains X and Y. Okay, so U, and then you have set containment with the curly brackets, and the elements X and Y are separated with this comma. The set A contains X. Okay. Any questions? Let's okay. Let A and B be sets. Okay, so A union B is the set. Let's do this. Okay, of all x in the universe, such that x is in A or x is in B. Okay. There's A intersected with B. So for intersection, you have and. So it's the set of x in U where x is in A and x is in B. So with or, it can be here, it can be there, it can be in both. This set and means it has to be in both A and B at the same time. Last one is
that
A.
a U after?
Sorry, what was that?
Is that a U after? So like the bottom one, X in U, such that.
Yes. Yeah, X in U such that it's in A and B. Okay, a complement. Okay. So the complement of A is the set of elements that are not in A. So your set of X in U such that X is not in A. Okay, so I have a lot of examples. First one, we'll have our universe contain the elements 1 through 5. So A will, we'll see, I have A equal to the set that contains 1, B contains 4 and 5. First thing is a Venn diagram. Okay, so universe, A and B, I'm going to have them overlap just in case. One is in A but not in B, so don't let that be in the set B, just in set A. 4 and 5 are in the set B, but not in set A, so don't let it be in set A, put it over here. And then don't forget your other elements. You've got 1, you need 2, and then 3, 4, 5. So we want to get the intersection, union, and complement of A. So it can be in set A or B or both. So you've got 1, 4, 5 in curly brackets. Someone tell me what A intersect B is?
One, 4, and 5.
Well, that was A union B. So the intersection is that they have in common. So,
2 and 3.
oh, actually, that would be the complement of A, which I'm going to write down. But
Empty bracket.
A and B is actually empty. There's nothing in common with either of the sets. So we're going to put this simple. Or you can write like this. Okay. We still have the picture, which helps. Okay, so we actually found the set A complement the elements that are not in A. So block A, it leaves 2, 3. Actually, I'm missing some, 4 and 5. Okay, but thanks for helping. Let's try B complement. So everything that's not in B, 1, 2, 3. Okay, so let's start again. Example number 2. I have a universe that contains -2. U equals set -2. 0, 1, and 2. Okay, A contains -2 and 1. Okay, let me see. I have a question on the side. We'll get to that. 1 second. Okay, so I have -2 and 1 in A. B is going to contain 1 and 2. We're going to pause for a second. I just want to mention that I would not suggest buying a book or anything for this class. I think that you'll do just fine with meetings or homework, but we're only going through 3 sections of the entire book, so I think it wouldn't be a good purchase. So, yes, a picture would be good. Okay, so A contains -2 and 1. B also contains 1 and 2. So we're going to put 1 in the intersection, the overlapping part right here. -2 is in A, but not B. 2 is over here. And you need to, don't forget 0. So put 0. I think that's everything. So let's make sure I got all my elements. Yes. Okay, so A union B is the set A with set B. So -2, 1, and 2. A and B. So what they have in common is that element 1. Let's get A complement. So not -2 or 1. So you can have 0 or 2. With the picture, you just block out this set. 0 and 2 is left over. And then contain them in a set of curly brackets. All right, we're going to switch it up. It's the same kind of stuff, but instead of numbers, we're going to use letters. So your universe has A, B, C, D, E, F, G. Let's go like this. Okay, in A, I put the elements A, C, E. Okay. B contains A, E, H. Actually, I put A, B, E, H. Oh, there is no H. Cool. A, B, E, G. And we'll just go through the same stuff with drawing a picture and finding some relationships between the sets A and B. Give me space. Okay, I would probably start with the intersection. So what elements are common to A and B? You've got A in both sets. And E. Okay, don't forget about C is in the set A. B and G are over here. Set B. There's A, B, C, D. E, F somewhere here, and then G is the end. Okay. And make sure everything's good before we erase. Yeah, we don't put find. Let's just put this stuff down. A, B. Okay, so the union is elements that are in A or B. So this set with that set will have C, A, E, B, G. And then close the set.
Is there specifics where does it matter if it has to be alphabetical or can it just be in order as we?
It's, yeah, it can be, it's not any different if you change like, just as long as you have all the same elements. Yeah, A, C. It's the same set if you just rearrange it. let's do the intersection. You can put E and then you put A. Okay, A complement. Elements that are not in A would be D, F, B, and G. Okay, I think this will be the last example. And I have a few more definitions for the notes today. Okay, so we're going to put W, X, Y, Z in our universe. So I am going to change the name of the sets. We're going to put capital E equal to the set that contains X and Z. We're going to make capital F put it equal to the set that contains Y. And we'll do the same process of drawing a Venn diagram here.
I'm sorry to interrupt. So how do we determine which letters go in each set?
Oh, well, as far as like this part goes, you're given all of this. I would tell this to you, and then you're asked questions after that.
Okay, gotcha. Thank you.
Yeah. So I would say something like, assume that. Then we're gonna go find. Yeah. So simply find A union B.
Gotcha. Thank you.
Actually, I think it'd be nice to draw a picture first. So, but thanks for the question. Okay, so there are no elements in common, so the intersection will be empty. We have X and Z in E. Y is in F. We need W somewhere like outside of each set. Okay, A union B. Oh, I'm sorry. E union F.
I have a question. I noticed that you put the U, like sometimes you switch it up, you put it on the left side or the right side. Does it matter?
No, it's a label. Yeah.
Okay.
Some people will make a little mark so it's like U is here, E is there, and F is there. It's the same. Okay. E union F contains X, Z, and Y. So, and that's E or F. E and F. Oh, it's empty. So you can put empty bracket. symbol for the empty set. Let's get E complement. Okay, so outside of E, the elements are the elements W and Y. Okay, we'll get F complement. So since F contains Y, you want all of the elements in the universe except for Y. So W, X, and Z. Okay, so we're using this kind of idea in this section and the next section. It'll come up again in probability, all of the sets and everything. Let's do some definitions for chapter 15. Okay. So we'll do a bunch of definitions, a couple of examples, and then next time we'll get into some more about variables. So we're going to do the definition of a variable. Okay, a variable is a characteristic that can assume different values. All right, next definition. Okay. Well, I just have a note actually. Variables are either qualitative or quantitative. Okay, we'll do qualitative first and then quantitative. Qualitative is like quality, so a qualitative variable actually put qualitative variables we'll say produce data that cannot be ranked or measured. Okay, examples are like eye color, can assume like that characteristic can assume values of like green and brown and blue, different colors. Another one is gender or blood type. Languages. We'll leave it like more examples later, maybe. Okay. Quantitative variables can be ranked or measured. So it's like a quantity. Sorry if I write fast. Can be ranked or measured. Actually, I should put a little bit more in there. Quantitative variables actually produce data that can be ranked or measured. Okay, so quantities like weight or height. Distance, time. Anything else? I have temperature. We'll just leave. Okay, last part is I have a picture of, oh, actually, I wanted to find data and then draw a picture. Okay, so the list of observed values for a variable is data, is called data. Okay, now we can draw a picture. So we were talking about variables. They can be qualitative or quantitative. So actually, there's no overlap. Let me kind of switch this over here. So different types of variables. This kind of variable, quantitative, can be discrete or continuous. Again, there's no overlap there. Okay, I think we want to do those definitions for discrete and continuous next time. We'll end it there. Again, there's no homework this week. We'll start doing homework next week. Let me know if you have any questions about the class, and have a good day. Thank you.
Thank you.
Thank you so
I
much.
have I have a question.
Yeah.
It's just some stuff I can't read, and I want to make sure I have it down right. Where it says the list of, what is the next word?
Oh, observed values.
Oh, okay. And then for the quantitative variables, what is the two that connects to it? Say continuous and discrete.
Yes.
Okay, thank you.
Oh, we're gonna
I just
start.
wanted to